This is expert TA number 9 on torque. This is problem number 9. The uniform boom shown below weighs 700 newtons and the object hanging from its right end weighs 400 newtons. The boom is supported by a cable. So here I have the boom and you can see each angle, and I drew it out over here so you can see the forces. So we have the force of tension in the y direction, the force of tension in the x direction, the force of the hinge in y direction, and the force of the hinge in the x direction, and these two are equal. So part A says calculate the tension in the cable. We're going to start out by, because this boom is not moving, the sum of the forces are always going to be equal to 0. So the sum of the forces in the x are equal to 0, and the sum of the forces in the y are equal to 0. So we're going to start off with our x forces. So we have the force of the hinge in the x direction minus the force of tension in the x direction are equal to 0. And we have the force of the hinge in the x direction is equal to the force of the tension in the x direction. And here's the force of the hinge in x. So the force of the hinge in the x, because we're calculating the tension, is equal to, right here, this is going to be t cosine theta. So that is equal to t cosine theta, and our theta for this is 45 degrees from right there. Now for our y, we have the force of the hinge in the y plus the force of the tension in the y, and this is plus because they are both going in the same direction and the x are going in opposite directions. But we have more forces in the y because we have got this force down here of this 200 Newton mass, and we have a 700 Newton. This should be much shorter. Let's make this right here. 200 newtons, and this is 700 right there. So minus 400, we know these forces, minus 700 is equal to 0. Those are all our forces in the y direction. So we have that, our forces in the x and y, and the sum of the torque is going to be equal to 0. So t sine theta times r minus 400 sine theta r minus 200 sine theta r times 1/2 r equals 0. And this is to find the torque, and we can cancel out all the r's because we don't need to know that. And just wanted to write down our angles. 65, 70, and 70. So our given angles. So we have t sine of 65 minus 400 sine 70 minus 200 sine 70 times 1/2 equals 0. And if I eventually put this all into my calculator to solve for t, I will find that t is equal to 772.89, and that is our tension. And part B says calculate the force of the hinge on the boom, and this has to do with how the object's in equilibrium. Because it's in equilibrium, we know that this tension we found here, this is the tension, it's going to be equal. So the force of the hinge on the boom is also going to be equal to 772.89 newtons. And this is also in newtons. And then part C asks, does the force of the hinge act along the boom? And the answer to that is no, because it's in equilibrium. They are not acting upon each other. So this is the work for expert TA number 9 on torque. Problem number 9.